Hello and welcome again. This is your host Harshit Sinha with another interesting topic, rethinking product design for a circular economy, which is considered the most burning topic in the waste management sector. Rethinking product design for a circular economy is essential for sustainable development. Traditional linear economies follow a take-make-dispose model, which leads to resource depletion and environmental degradation. In contrast, a circular economy emphasizes the reuse, repair, refurbishment, and recycling of products and materials, aiming to close the loop and minimize waste. Designing products with a circular mindset involves several key principles. Firstly, durability and longevity are prioritized to extend the product's life cycle. Designers must consider how products can be easily disassembled, repaired, or upgraded. This reduces the need for new raw materials and decreases waste. Secondly, selecting sustainable and recyclable materials is crucial. Materials that can be safely returned to the environment or reintroduced into the production process without losing quality contribute to a circular system. Thirdly, modularity and standardization play a significant role. Interchangeable parts and components enable easy upgrades and repairs, fostering a culture of maintenance rather than disposal. Additionally, integrating circular economy principles into product design encourages innovation and new business models such as product as a service or leasing, which promote product longevity and resource efficiency. Let us explore the important aspects of the topic in brief. Transitioning to a circular economy requires a fundamental redesign of our current economic model, focusing on closed-loop supply chains, circular product design, and systematic change. Closed-loop supply chains are central to this transformation. Unlike traditional linear supply chains, closed-loop systems ensure that materials are continuously reused rather than discarded. This involves recovering, remanufacturing, and recycling products at the end of their life cycle to minimize waste and reduce reliance on virgin resources. Companies like Dell and Apple have pioneered such practices by reclaiming materials from used electronics to produce new products. Circular product design complements closed-loop supply chains by integrating sustainability into the very foundation of product creation. This includes designing for durability, repairability, and recyclability while minimizing resource use and waste. For example, modular electronics allow easy repairs and upgrades, significantly extending product life cycles. Design strategies like biomimicry, cradle-to-cradle principles, and eco-design further support a closed-loop system. Achieving these goals demands systematic change across economic, regulatory, and social dimensions. Collaboration between governments, businesses, and consumers is essential to drive policy reforms, adopt sustainable practices, and shift consumer behavior toward valuing reuse and repair. Regulatory measures like extended producer responsibility, EPR, encourage companies to innovate in product lifecycle management. By rethinking our economic model, we can reduce environmental impact, enhance resource efficiency, and foster long-term economic resilience, paving the way for a sustainable future. Redesigning the service sector to embrace the principles of product as a service, the sharing economy, and promoting circular business models is essential for sustainable development. Product as a service, PaaS, transforms traditional ownership models by offering products as a service rather than selling them outright. This approach encourages manufacturers to retain ownership of their products, fostering a vested interest in durability, maintenance, and end-of-life recycling. For instance, companies lease equipment or appliances, ensuring regular updates and efficient use, thereby reducing waste. The sharing economy promotes the collaborative use of resources, reducing the demand for new products. By facilitating the shared use of goods and services, platforms such as ride-sharing, accommodation sharing, and tool libraries optimize resource utilization and minimize environmental impact. This model not only offers consumers affordable access to a wide range of services, but also reduces the overall consumption of resources. To promote circular business models, businesses must rethink their operations to prioritize sustainability. This involves designing products for longevity, repairability, and recyclability. Companies can adopt strategies such as take-back schemes, where used products are collected, refurbished, and reintroduced into the market. Additionally, businesses can explore innovative models like subscription services, where customers subscribe to a service that provides continuous product updates and maintenance. Integrating these approaches within the service sector can lead to significant environmental and economic benefits. By shifting away from linear consumption patterns, we can reduce waste, conserve resources, and promote a more sustainable and resilient economy. Life cycle analysis, LCA, is a comprehensive methodology to assess the environmental impacts of a product from its inception to its disposal. By evaluating each phase of a product's life, LCA helps identify opportunities for improving sustainability. 1. Design phase. The design phase is critical as it sets the foundation for a product's environmental impact. Sustainable design focuses on selecting eco-friendly materials, minimizing resource use, and ensuring the product can be easily disassembled for repair or recycling. By incorporating principles such as durability, repairability, and recyclability, designers can significantly reduce the product's environmental footprint. 2. Manufacturing phase. The manufacturing phase involves the conversion of raw materials into finished products. This phase often consumes significant energy and resources and generates waste. Implementing efficient manufacturing processes such as using renewable energy, minimizing material waste, and recycling byproducts can mitigate environmental impacts. Closed-loop systems where waste materials are fed back into the production process are particularly effective. 3. Use phase. During the use phase, the product's performance and longevity are crucial. Products designed for energy efficiency, durability, and ease of maintenance reduce the need for frequent replacements and minimize resource consumption. Educating consumers on proper use and maintenance further extends the product's life and enhances its environmental performance. 4. End-of-life phase. The end-of-life phase focuses on the product's disposal or recycling. Effective strategies include designing for disassembly, facilitating recycling, and implementing take-back schemes where manufacturers recover and recycle used products. By ensuring materials can be safely returned to the environment or reused in new products, the circular economy is supported, reducing waste and conserving resources. Rethinking product design for a circular economy requires a holistic approach that emphasizes durability, repairability, recyclability, and remanufacturing. These principles ensure that products and materials remain in use for as long as possible, reducing waste and conserving resources. 1. Durability. Designing products for durability means creating items that can withstand wear and tear over time. This involves selecting high-quality materials and robust construction methods that extend the product's lifespan. Durable products reduce the need for frequent replacements, which in turn minimizes resource consumption and waste generation. 2. Repairability. Incorporating repairability into product design allows consumers to fix and maintain their items rather than discarding them. This can be achieved by using standardized and easily replaceable components, providing repair manuals, and ensuring access to spare parts. Encouraging repairability not only extends the product's life, but also fosters a culture of maintenance and resourcefulness. 3. Recyclability. Recyclability focuses on designing products with materials that can be easily separated and reprocessed at the end of their life. Using monomaterials or materials that are compatible with existing recycling systems ensures that products can be efficiently recycled. Clear labeling and design for disassembly further facilitate the recycling process, reducing the environmental impact of waste. 4. Remanufacturing. Remanufacturing involves refurbishing and restoring used products to their original condition or better. By recovering valuable components and materials, remanufacturing conserves resources and reduces the need for new raw materials. This process not only extends the life of products, but also provides opportunities for innovation and cost savings. By prioritizing durability, repairability, recyclability, and remanufacturing in product design, we can create a more sustainable and circular economy, reducing waste and conserving resources for future generations. A reverse supply chain is a critical component of a circular economy, focusing on the return flow of products and materials from end users back to the producers. This process comprises several key stages: collection, sorting, processing, and distribution. Collection. The first step in a reverse supply chain is the collection of used, defective, or end-of-life products from consumers. This can be facilitated through various means, such as take-back programs, return policies, and designated collection centers. Efficient collection systems ensure that a large volume of products is gathered for further processing, thereby reducing waste and conserving resources. Sorting. Once collected, the products undergo sorting to categorize them based on their condition, material composition, and potential for reuse or recycling. This stage is crucial for optimizing the subsequent processing steps. Advanced sorting technologies such as automated sorting machines and manual inspection help segregate materials accurately, ensuring that they are directed to the appropriate processing streams. Processing. In the processing stage, the sorted products are treated to recover valuable materials and components. Depending on the nature of the products, this may involve disassembly, refurbishment, remanufacturing, or recycling. For instance, electronic waste is dismantled to extract precious metals, while plastic items are shredded and melted for reuse. Effective processing maximizes the recovery of resources and minimizes environmental impact. Distribution. The final stage of the reverse supply chain involves redistributing the recovered materials and refurbished products back into the supply chain. This can include selling refurbished goods, supplying recycled materials to manufacturers, or reintegrating remanufactured components into new products. Efficient distribution ensures that the reclaimed resources are utilized effectively, closing the loop and supporting a sustainable circular economy. Circular economy principles are fundamental for creating a sustainable and resilient economic system. These principles include waste elimination, resource efficiency, the use of renewable energy, and system thinking. Waste elimination. At the core of a circular economy is the principle of designing out waste. Instead of following a linear take-make-dispose approach, products and processes are designed to minimize waste at every stage. This involves creating products that can be reused, repaired, refurbished, or recycled, thus reducing the need for new raw materials and decreasing environmental pollution. Resource efficiency. Efficient use of resources is crucial in a circular economy. This means extracting maximum value from materials and products throughout their life cycles. Strategies such as designing for durability, modularity, and easy disassembly, as well as promoting sharing and leasing models, help optimize resource use. Resource efficiency reduces material costs and environmental impact, contributing to sustainable economic growth. Renewable energy. The shift towards renewable energy sources is essential in a circular economy. Using renewable energy such as solar, wind, and hydropower reduces reliance on finite fossil fuels and decreases greenhouse gas emissions. Integrating renewable energy into production processes and supply chains supports the transition to a low-carbon economy and enhances energy security. System thinking. System thinking involves understanding and managing the interconnections within and between systems. In a circular economy, this means considering the entire value chain and the interactions between different economic, social, and environmental factors. By adopting a holistic perspective, businesses and policymakers can identify synergies, optimize resource flows, and create systemic change that supports sustainability. Circular product design strategies are essential for creating sustainable products that minimize waste and promote resource efficiency. 4 key strategies are: design for disassembly. This strategy focuses on designing products so they can be easily taken apart at the end of their life. By using simple connections and avoiding adhesives or mixed materials, products can be disassembled into individual components for repair, refurbishment, or recycling. This not only reduces waste but also facilitates material recovery. Modular design. Modular design involves creating products with interchangeable and standardized parts. This allows for easy replacement, upgrade, or repair of individual components without discarding the entire product. Modular design enhances the product's adaptability and extends its useful life, reducing the need for new resources. Material selection. Choosing sustainable and recyclable materials is crucial in circular product design. Materials should be non-toxic, renewable, and easily recyclable. Designers should prioritize materials that can be recovered and reprocessed with minimal environmental impact. By selecting appropriate materials, the product's overall sustainability can be significantly improved. Product life extension. Extending the life of products involves designing them for durability, repairability, and upgradability. This can be achieved by using high-quality materials, providing repair manuals and spare parts, and designing for future upgrades. Products with longer lifespans reduce the demand for new resources and decrease waste generation. Implementing these circular product design strategies can lead to significant environmental and economic benefits. By focusing on disassembly, modularity, sustainable materials, and longevity, designers can create products that contribute to a more sustainable and resilient circular economy. The circular business model revolves around maximizing resource efficiency, minimizing waste, and extending product life cycles through innovative practices. 3 key components of this model are product as a service, PaaS, remanufacturing, and sharing platforms. Product as a service, PaaS. PaaS shifts the traditional ownership model to a service-oriented approach. Instead of selling products, companies offer them as services, retaining ownership and responsibility for maintenance and end-of-life management. This model incentivizes manufacturers to produce durable, high-quality items that require minimal repairs. For instance, companies may lease equipment, provide subscription-based services, or offer pay-per-use options. PaaS not only extends product lifespans, but also reduces waste by promoting reuse and efficient resource management. Remanufacturing. Remanufacturing involves restoring used products to their original or better condition. This process includes disassembly, cleaning, repairing, and reassembling components. Remanufactured products meet the same standards as new ones, but with significantly lower resource consumption and environmental impact. By recovering valuable materials and parts, remanufacturing conserves resources, reduces emissions, and offers cost-effective alternatives for consumers. Industries such as automotive, electronics, and heavy machinery widely adopt remanufacturing to achieve sustainability goals. Sharing platforms. Sharing platforms facilitate the collaborative use of goods and services, reducing the demand for new products and optimizing resource utilization. These platforms enable individuals and businesses to share access to underutilized assets such as vehicles, tools, and accommodations. Examples include ride-sharing services, tool libraries, and peer-to-peer rental platforms. By promoting shared use, these platforms decrease the overall consumption of resources, minimize waste, and enhance economic efficiency. Incorporating PaaS, remanufacturing, and sharing platforms into circular economy business models fosters a circular economy, contributing to sustainability and resource conservation. Reverse logistics is an essential aspect of a circular economy. Focusing on the backward flow of products and materials from consumers back to producers for recovery and reuse. The key stages of reverse logistics include collection, transportation, sorting, processing, and redistribution. 1. Collection. The first step involves gathering used, defective, or end-of-life products from consumers. Effective collection systems such as take-back programs, drop-off points, and return policies ensure that a significant volume of products is retrieved for further processing. This step is crucial for diverting waste from landfills and enabling resource recovery. 2. Transportation. Once collected, the products must be transported to processing facilities. Efficient transportation logistics minimize the environmental impact of moving goods. This can be achieved by optimizing routes, consolidating shipments, and utilizing eco-friendly transportation methods. 3. Sorting. At the processing facilities, products are sorted based on their material composition, condition, and potential for reuse or recycling. Advanced sorting technologies such as automated sorting machines and manual inspection help accurately categorize materials, ensuring they are directed to appropriate processing streams. Proper sorting is vital for maximizing the efficiency of subsequent processing steps. 4. Processing. During the processing stage, the sorted products undergo treatment to recover valuable materials and components. This may involve disassembly, refurbishment, remanufacturing, or recycling. Effective processing techniques maximize resource recovery and minimize environmental impact by reducing waste and conserving raw materials. 5. Redistribution. The final stage involves redistributing the recovered materials and refurbished products back into the supply chain. This can include selling refurbished goods, supplying recycled materials to manufacturers, or reintegrating remanufactured components into new products. Efficient redistribution ensures that reclaimed resources are utilized effectively, closing the loop and supporting a sustainable circular economy. Circular supply chains emphasize sustainability by ensuring that materials and products are reused, recycled, and remanufactured throughout their life cycles. This approach comprises several key stages: design, manufacturing, distribution, use, and recovery phases. 1. Design phase. In a circular supply chain, the design phase is pivotal. Products are designed with longevity, reparability, and recyclability in mind. Designers prioritize the use of sustainable and non-toxic materials, ensuring that products can be easily disassembled and reprocessed at the end of their life cycles. This proactive approach reduces waste and facilitates resource recovery. 2. Manufacturing phase. During the manufacturing phase, resource efficiency and waste minimization are crucial. By incorporating renewable energy sources, reducing material waste, and implementing closed-loop processes, manufacturers can significantly lower their environmental impact. The aim is to create products with minimal resource input and maximum output efficiency. 3. Distribution phase. Efficient and sustainable distribution systems are essential. This involves optimizing logistics to reduce transportation emissions using eco-friendly packaging and implementing reverse logistics for returning used products. Efficient distribution minimizes the carbon footprint and supports the circular flow of materials. 4. Use phase. Extending the use phase of products is a core principle of circular supply chains. This can be achieved by designing products for durability and easy maintenance. Providing consumers with repair services and encouraging the reuse of products through leasing or sharing models reduces the demand for new items and conserves resources. 5. Recovery phase. The recovery phase focuses on reclaiming products and materials at the end of their life cycles. Effective strategies include take-back schemes, recycling programs, and remanufacturing processes. By reintegrating recovered materials into the production cycle, waste is minimized and resources are conserved. Circular economic metrics are essential for evaluating the effectiveness of circular economy initiatives. These metrics help in measuring the sustainability and efficiency of resource use, ultimately guiding decision-making and policy development. 4 key metrics are the Material Circularity Indicator, MCI, waste diversion rates, product lifespan, and resource productivity. Material Circularity Indicator, MCI. MCI measures the extent to which a product or a company's material inputs are circular. It considers factors such as the amount of recycled content used, the recyclability of products, and the efficiency of resource use. A higher MCI indicates a higher degree of circularity, signifying that materials are kept in use for longer and are effectively cycled back into the economy. Waste diversion rates. This metric quantifies the percentage of waste materials that are diverted from landfills and incineration to be recycled, reused, or composted. High waste diversion rates indicate successful waste management practices and a reduced environmental impact. Tracking these rates helps identify areas for improvement in waste reduction and resource recovery efforts. Product lifespan. The lifespan of a product measures the duration a product remains functional and in use. Extending product lifespans through durable design, repairability, and refurbishment reduces the demand for new resources and minimizes waste generation. This metric highlights the importance of designing products for longevity and promoting a culture of maintenance and reuse. Resource productivity. Resource productivity measures the economic output generated per unit of resource input. It assesses how efficiently resources are utilized in production processes and the overall economy. Higher resource productivity signifies better use of materials, leading to cost savings and reduced environmental impact. This metric encourages businesses to optimize resource use and adopt sustainable practices. So here we end this interesting topic, which is the summary of the various aspects on rethinking product design for circular economy. To sum up, we have introduced this topic in the beginning with short description, followed by the narration of the redesigning of our economic model as well service sector. Further, we explained about life cycle analysis, rethinking product design, reverse supply chains, and principle of circular. To materialize the new product design, we briefly narrated circular product design strategies and circular business models. To strengthen the new product design, we specifically explained about reverse logistics, circular supply chains, and to judge the performance of the new product design, we gave the description of the circular economic metrics. Well, the viewer will be made surprised with the description of the related topic to circular economy. So, stay tuned till next week before we dive into the related aspects of circular economy with 2 or 3 episodes on extended producer responsibility, i.e., largely known as EPR. Till then, wish that the viewer would have enjoyed celebration of Valentine's Day with someone somewhere as you all like it.